Hi, my name is Gregg Pasquarelli. Good morning to everyone, and thank you, Martha, for inviting us to be here today. Can we get the presentation up? I'm going to talk a little bit about the firm that I started called Shop Architects, along with, there were three names, Sharpless, Holden, Pasquarelli, that came together to form Shop. We all came from different backgrounds before we came to architecture, and so I think it gave us a sort of desire and ability to be critical about the way that the design process and the making of cities gets executed. And from the first day, we thought of ourselves as being equally thinkers and makers, that we loved research, we loved theory, we loved putting all these things together, but we were super interested in how buildings are made, produced, fabricated, delivered, assembled, and the kinds of impacts and effects that they have on the built environment. We tend to not have a sort of standard style, but when we start a project, we really think about asking questions. And the questions are, varied and different, and try to think about ways in which we can assemble new combinations using new technologies to make a more sustainable, just, and interesting urban fabric. This is not going. Can we move it forward one? Well, we could ask more questions, too. Can somebody help move that forward? Seems like it froze. Okay. So I think that one of the things that we did, I'll just tell you, was we started to question the way in which drawings were made, the way in which we documented not only the buildings that we wanted to make, but the cities that we wanted to have to be in the future. And so oftentimes we realized that the way in which architects communicate was not necessarily the sort of best way to do it, so that we started to think about new ways of drawing, new ways of production, and thinking about buildings more like products, and thinking about, and instead of construction, more like manufacturing. And very early on in our research, we did some very small buildings that helped us begin to think about that, where the actual drawing set was very different. It was either instructions for machines to make the parts, and then sort of visual instructions for people to put those parts together. Let's hope this guy works. And then even the kinds of drawings that we're doing inside the studio right now, we realized that looking at plans, sections, and elevations, as architects and designers and city makers, we think in 3D, 4D, 5D, but then really we reduce a lot of that intelligence into 2D and then hand it to people who have to take that 2D information and bring it back out to 3D. And what we've learned is that working with, if you really want to make these kind of special buildings, that you need new kinds of drawing techniques in order to help people understand what you're doing, how it goes together, what the materials are, what the efficiencies are, and how to do it. And so we've now been pioneering technologies where the construction workers look at the models in the goggles and in the field and understand exactly what they're supposed to do before they have to do it. And it creates a tremendous amount of clarity and transparency and efficiency in the project as a whole. And then that's the little building that we did, which was the first building that was completely fabricated in the United States, the first building that was completely fabricated by the computer. As an innovative firm, we also have created other kinds of software that have spun out of Shop. We created a company called Envelope, which can take any site. We started in New York, but it's now going around the country, and we've had some interest from investors in Asia and in Europe, where it can take the zoning code and the building code and a property, and what would normally take a very good architect or land use attorney somewhere around 12 hours to figure out, you could do it on your iPhone in less than 60 seconds and tell you exactly what you can build, all your options, you can model it, and it outputs it both simultaneously to Revit to start your architecture drawings, but then also into the spreadsheets to run financial models simultaneously, so that you can move the architecture around and watch the impacts on the materials, the cost, and how long it would take to get built. To our very first building where we joint ventured as a developer, this was a building called the Porter House in the Meatpacking District. It was the first fully digitally fabricated facade in 2000, which had no drawings whatsoever. but went straight from a 3D model to producing 4,000 panels to going up onto a building, which was a mix of a kind of modern new building over a landmark building, historic building below. And again, this was an innovative thing, not only how we built it, but that we took an equity position in the project. And it was only because we took that equity position did our partners have or allow us to try something so new as the first fully digitally fabricated facade in Rain Scream in New York. And only 5 years later, because we had sort of taken some risks on how you put that together, we were challenged with doing the Barclays Center, which was the new NBA home for the Nets in Brooklyn, where we did 11,500 different shaped panels of Corten steel on 920 mega panels. We wrote all the code, all the software, produced all the fabrication tickets, wrote our own iPhone app that tracked the entire process from cutting to weathering. All the panels were hung on these dry cleaner racks and went through 15 wet-dry cycles a day for 4 months to put 10 years of the patina on the project. And then it was all delivered and put onto the building, and it went together in record time. And so it was so interesting that going from a 50,000 or 5,000 square meter project and testing out these new ideas led us to the sort of billion-dollar stadium only 5 or 6 years later. And then you could see the interior, which was really about a sort of black box theater. And it was also a very interesting project, and it was the first stadium in the United States ever built with 0 parking spots. And that the whole project was built around that it was prioritized experience for those who come by public transportation over private transportation. Other ways that we've used technology is we were challenged to take this landmark building in downtown Brooklyn as well, had a spectacular interior, was completely falling apart, needed a lot of revenue to restore this building, but we wanted to propose putting this would be about a 350-meter tower on top. But it was on a landmark building, and so we had to do something to get the approvals of the process of the project. And we did it through this idea of taking sort of convex and concave fluting of columns, and then brought those two together into what we called the convexicave pilaster. And we took those pilasters and wrapped them around the rest of the site. And the city and the Landmarks Commission was sort of so excited by what we were doing in making this connection of old and new that they, you could see this new base in the historic building on the back, that they approved this 1,066 foot tall tower to be integrated on the site. We used the roof of the historic building to be the sort of amenity space. And my favorite part is that we put the swimming pool around the dome of the building, so while you're lying there in the pool, the historic object comes up out of the water. And there you could see the tower. And then sorry about the sound, but we've developed this app where you could then go to the landmarks and the city people and just show them what the building will look like when it eventually gets built. And it really helped us tremendously in getting it approved. And so you could do that in live time. Let's keep going. Did we freeze? There we go. And it will be the tallest tower and the only 1,000-foot building outside of Manhattan when it's finished, and we're under construction on it right now. Another way we've done that, I mean, it's all well and good to do it in these kinds of technologies in places like New York City where there's a lot of skilled labor. But then this is a project that we are doing in Botswana, Africa. It's and you can see sort of these are the ways that we sort of track the way that we build projects. And so it was really about doing this government complex. And this is software that we keep in the office to help us track the way we put these together. But we literally design every single part in the facade systems, and then we break them apart. We know every single piece. It's completely tracked, and we can send it to dozens, if not hundreds or thousands of different fabricators, and they just get the instruction set digitally for how to fabricate each piece that's out there. Then the pieces are sent, and then they're assembled, sort of like the best IKEA furniture you could ever imagine. And we track these, and then we're able to know exactly where the parts are. They're numbered, they go together, And it's a very easy way to begin to build really beautiful, high-quality kinds of buildings at a very affordable price around the world. And so here you could see those pieces as they come in parts, and then they snap together and go on the building. And this is the building a couple months ago. It's just getting towards its finish. So this is doing this kind of thing in a place that has very little skilled labor. We've spent a lot of time with knowledge transfer. We brought some of the equipment, fabrication equipment, down to Gaborone in Botswana, and it's amazing how the building has gone together. To another way of using technology, again, this is a sort of living, breathing building that we're doing for Uber's headquarters in San Francisco. And so the idea, Ben, it was great seeing your data about using the stairs. It was the same exact idea. And so the building, basically, only 60% of it is air conditioned and 40% of it is not air conditioned. And the building, the facade lives and breathes, and it's basically built around a whole series of staircases and meeting rooms. And every single place that you collaborate, it happens sort of within this front porch of two buildings that are then connected by bridges. And it was a huge amount of modeling on the sort of data and the biophilia and the way in which we're putting the plantings in to help create and temper the microclimates in the building itself. So here you could see kind of walking through those spaces. And then the entire facade is made up of bronze doors that are 5 meters by 2 meters, and they open and close automatically based on the local microclimates that are going on inside the building. And then basically the facade of the building, or the symbol that the company is showing out to the public, is watching the collaboration of all the people that are there working together. So the people become the facade itself. And here it is under construction. It should be finished in about a year. Here you can see the bridges making the connections between the two. To other sort of experimental work that we've done just with materials. This was with a digital extruder of ceramics and using digital cutting elements in order to play with terracotta. This was for a pavilion that we did at the Milan Furniture Fair a couple of years ago. But just by adapting new technologies and digital technologies to a very traditional material, we're able to make something that we thought was incredibly beautiful. It was very reasonable and inexpensive to make, but gave us a lot of research into ideas about using terracotta in new ways. And it was a really fun project that I think helped inspire us as we were working on another project that we're doing right now. This one is on 57th Street in Midtown Manhattan, and this is about a 440-meter tall tower under construction, but it's only 20 meters wide. So it'll be the most slender tower in the world when it's completed. And then the facade itself was a sort of system of using extruded, computer digitally fabricated terracotta and cast bronze in the filigrees, which sort of wrapped onto the shear walls that held the building up, and that each one of these pilasters became one of the setbacks to create a new kind of silhouette building. You know, we all know the sort of traditional setback buildings where they go like this. Many of the contemporary buildings, the glass goes on an angle. We wanted to do something that was very different, that both looked back at the history and DNA of the skyscraper, but also looked forward by having this sort of micro setback system. And then, I literally took this with my iPhone about a month ago, but so it's not a very high quality photo, but here you could see the terracotta, because we were able to rotate it because of the way we were fabricating it. It was okay to make 26 different shapes and 6 different colors of cream, and that it rotates back and forth so that when the sun hits it from the south, it creates these sort of arcing patterns of shadow and light on the tower as it goes up. Each apartment has a 20-meter living room facing Central Park. No, this is not part of New York City's affordable housing buildings, program. But again, here you could see the tower from Central Park. This was just taken a couple months ago. And we're literally putting in the last 20 pieces of steel in the coming weeks. And so, it's a kind of remarkable building and one that's been super interesting for us to work on, to think about a building that we all have to live with every day and to make something that's very beautiful and something that connects to the history but is absolutely very contemporary and looking forward. And so I think that using a lot of this technology has been, there you could see the sort of shadows and light on the side of the terracotta as you look up from the tower. And what it looks like and its location to Central Park. So, I think that as designers, as city makers, as people who deeply care about quality of life and the way that we think about things, that technology is really, it's important that we don't think of it as just technology, but we think of it as something that inspires beauty, that makes wonderful places, that has a high quality of life. The most sustainable thing you can do is not cover a building with photovoltaics or any kind of technology. It's to make buildings that people love and take care of over time. It's about making them dense and making them connected to mass transit. And if you're going to do that, you also have to invest incredibly in public space. Because if we're going to live in these very dense, packed cities, we need fantastic public space to make life bearable and enjoyable and inspirational. And so to us, it's really the beauty of that idea of thinking and living and being in these dense environments that are super sustainable, but using technology, not as we sometimes always think of it, but for actually bringing out the beauty in the world. And I think that that's always been an inspiration to us, and that beauty, technology, economy, really kind of come together, and we think that architecture and technology really, as they move forward in the future, have a very, very strong place to be hand in hand in the coming decades. Thank you very much.